Okay, hi guys. So let's do one example of the voltage regulator. So the first example saying, consider the voltage regulator is used to power the cell phone at 2.5 volt. So now we need to define what is the source, what is the load. So when saying to power the cell phone, so yes, cell phone will be your load from the lithium ion battery. So here will be your battery, will be your source. So from the battery, the voltage may vary between 3 and 3.6. So it means here your VPS here is a variable sources. So you have VPS minimum and VPS maximum. So what will be the VPS minimum is 3 volt. Your VPS maximum is 3.6 volt. The current in the phone. So the current in the phone means the current in the load. So this is your load. Will vary from 0 of 200 milliampere when talking. So what does this means here is your load current. That is your load current here is IL. So your IL is having minimum and maximum value. So your minimum value of your load current is 0 when off, 100 milliampere when talking. So 2.5 here. So consider the voltage regulator is to power the cell phone at 2.5 volt. So what does that mean by 2.5 volt? Means your load needed here is to power the cell phone. So you need the load voltage here is about 2.5 volt. So we can define your VL is equal to 2.5 volt. Since your VL here is parallel to your Zener diode, and again, your Zener diode here is operate at the reverse bias. So you can name here VZ. So you can equate your VL and your VZ are the same because they are parallel. So when they are parallel, the voltage are the same. So you can have VL equal to 2.5. Your VZ also is equal to 2.5 volt. So what the question wants? The question wants you to find the value of R in and the value of BZ. Okay, so after you have defined all the variables with the correct values, so you need to have the KVL equations here. So as we derived before, it will be the same equation minus VPS plus RI, I total plus VZ equal to 0. So take your RI out, so become VPS minus VZ divided by I total. What is I total? Use KCL, so become IL plus IZ. So you need to have two equations for RI. One is for minimum, another one is for maximum. So this when VPS is equal minimum, your IZ will follow, right? So it become minimum, your IL will become maximum. So when your VPS here is maximum, your IZ here will be maximum and here will be minimum. Okay. So now let's substitute all the value. So you are given VPS minimum here is 3, your VZ is 2.5, IL maximum is 100 milli, plus IZ minimum is not given. So this is RI. Another equation, RI equal VPS maximum is 3.6 minus 2.5. IL minimum is 0 and your IZ maximum is not given. So we have here two equation and one equation and two unknown, right? So that's why you need to have another assumption here where your IZ minimum will be equal to 0.1 IZ maximum. So now we have two equation, two unknown, so you can solve the equation. So here is the solution of the question. So the same. So you need to have this assumption IZ minimum equals 0.1 IZ maximum. So this assumption will be based on the question. So if it change to 0.2, you need to change it accordingly. So then you can get IZ maximum is 282.05 and then you need to substitute back to Ri, and then you can get the current limiting resistance here is 3.9 ohm. Second part of the question, it asks about maximum power dissipation. So when talking about power dissipation is equal Iz maximum multiplied by your Vz, the zener voltage. So just now you just need to substitute all the value, and what will be the power dissipation of the zener diode is around 705.13 milliwatt. So there are a few examples here. Try to do it by yourself. So here the question will always give the value of your VPS minimum and your VPS maximum, and sometimes it will give you the range of RL. So what you need to do with this RL? So RL is related to the IL, right? So when you have here VZ is given here 5.6. You know your VZ here will be always the same with your load, VL. So means your load also will be 2.5. So this question didn't give you the value of IL directly, but it gives you the value of RL. So you need to use Ohm's law, I equal VL over R over RL. So it depends on which one will be minimum, which one will be maximum. Here will become 2.5 over RL. So you need to calculate, means this is inversely proportional, right? So means for your IL minimum is will be having at 100 ohm. Your IL maximum will lead to the low resistance because this is inversely proportional. So once you got your IL min and IL max, you can calculate your Ri just using the KVL as usual. The second part, you will ask the maximum power rating. This one is the power dissipation of the zener diode. Again, use this formula. Iz maximum multiplied by Vz. Okay, so try to solve this question by yourself. Here is the answer. And we have another question here. This is example of previous written question. So it will give the same circuit. So what you need to do is you need to just rearrange the value given with the KVL equation. For example, this question, it already gives you Ri. So what you need to find is IL, Iz, and I total. And the second question, it already gives you the power dissipation of the zener diode. What you need to calculate is your RL. So hold the concept of the KVL here, and when your VPS is maximum, your Iz will be also maximum. When your VPS is minimum, your Iz will be minimum. Okay, so we'll discuss this in the next class. Assalamualaikum warahmatullahi wabarakatuh.